Hello, geometry geniuses. This is the kind of problem that gets me really excited about math because this is one where you really have to think and figure out how to solve this problem. Um, it says a circle inscribed inside a square. That means it's just drawn inside the square and it touches on all four sides. A circle is inscribed in a square as shown. If graphed on the coordinate plane, the coordinates of the center of the circle, so let's look at where the center would be. And again, this isn't like a construction or anything. I'm just estimating or eyeballing where the center of that circle would be. And they say that's at 3, 4. So that is the point 3, 4. All right, now they say that one other point on the circle would be at -1. So that would be left 1. That'd probably be around in here somewhere if I had to guess. It's going to be around in there somewhere. So I'm going to connect those dots. Now, what do we have when we have the center of a circle and a point on the circle? That is the radius. So that's the radius right there. Okay? And it tells me that that point is at well, I better write it on here, huh? I'm going to say -1, 1. All right? So now, what I need to do is I need to find the length of that radius. Now, if I have 2 points, and I need to find the distance between them. Do you remember what formula I need to use? Absolutely. We're going to use the distance formula. So let me change colors so you'll be able to see it here. So I'm going to use the distance formula, and always in my class, I always write the formula first before I do anything else. No matter what kind of problem I'm doing, I always write the formula first. So I'm going to do that here too. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So basically all we're doing is we're finding how much change is there in x and how much change is there in y. And the formula looks all complicated, but they actually give you this formula on the EOC. And so all you have to do is be able to substitute into it. So what I'm going to do, and I always do this too, is the center of my circle is at 3, 4. And I'm going to call that x1, y1. x1, y1. And then the point on the circle is at -1, 1. So I'm going to call that x2, y2. See, you can hear my puppies even excited about this kind of problem. So, and remember, x1, y1, all that tells you is, hey, this is the first point. It doesn't say you have to multiply it times anything or anything like that. That's just naming those points. All right, so I'm going to come over here, and x2 is -1, so I'm going to put -1 in there, minus x1, which is 3, and then I have to square it, plus y2 is 1, minus y1, which is 4. Okay, so all I did here was substitute. I just filled in those numbers. All right, now I'm going to simplify. I'm going to do what's inside the parentheses first. That makes sense, right? -1 minus 3 is -4 squared, plus 1 minus 4, that gives me -3 squared. And if those integers, these positive and negative numbers throw you off, stick them in your calculator, okay? Don't worry about it. Just stick them in your calculator. Make sure you get it right. All right, so -4 times -4 gives me positive 16, because I know that a negative times a negative is a positive. Here I've got -3 times -3 gives me positive 9. All right, now I'm going to add those bad boys together. 16 and 9 gives me 25. And I happen to know that the square root of 25, that's a perfect square, because 5 times 5 gives me 25. So I'm going to put 5 here. All right, so the length of my radius here, the length of my radius is 5. Let's see if you can see this color. 5. That's kind of hard to see, isn't it? All right, let me switch colors here. All right, so let's say we know that any radius of the circle is going to be 5, so this would be 5. What would this radius from here to here be? Oh, well, that would be 5 also. Well, look at that. What does that make the length of that side of my square. If it goes from this point to this point, that length of that side of my square is going to be 10. And of course, we know that squares, all the sides are equal. So this side will be 10, this side will be 10, this side will be 10. Now we can find the area of the square. So let's do that. I know that to find the area of a square, I multiply the length times the width, or a side times a side. We'll say length times width just to keep it consistent, equals the area. So 10 times 10 equals the area of that square. 10 times 10 is 100. So the area of that square is 100, and I guess it would just be units, blocks, whatever. So 100 would equal the area there. I used the radius to determine the diameter. Then I used the diameter to determine the length of the sides. Sorry, I know this was a long video, but this is a pretty cool problem, and I didn't want to leave it out there. So you guys go do number 38. Good luck on it, and I'll see you for number 39.